Thanks everyone so much for joining today. Hope you're staying safe. Hope you're staying healthy wherever you are in the world. I'm going to take us through about 5 or 6 key components in the platform today. Specifically, we're going to look at sort of the network governance layer. We'll look at the available protocol options on the platform and some of the more advanced configurations you can do at that layer or directly on your blockchain node. We'll look at some of the key management techniques that we have, specifically holding your private keys in a cloud HSM. I'll demonstrate Azure, but just as easy to do it on AWS. We'll look at HD wallets. We'll look at holding those private keys on the node. Some other approaches. We'll go through the digital asset and token functionality on the platform, and then we'll finish showing you sort of chain layer or application layer role-based access control, where you can apply really rich and sophisticated rule sets. This set of application credentials is allowed to do these things. This end user is allowed to call this smart contract or this method, about as granular or as expansive as you want. So really, really awesome feature. We call that a blockchain application firewall. I'm going to skip the slides today. There's many, many recordings on our YouTube channel if you want to go back and see other presentations and look at the slides. But specifically, we're gonna focus on these 3 layers here. So we'll look at the network layer, the control plane layer as we onboard new participants and embed governance. We'll look at the blockchain layer, of course, with the nodes and with those digital assets and tokens. And then we'll look at the member plane layer, where you can actually integrate those rich rule sets and you can integrate more advanced signing approaches like a cloud HSM, for example. So that's sort of the game plan for today, and we'll just dive through each of those components in order. So I'm going to hop over. I've logged into my account inside the platform. I have an existing network, and I'm just going to go ahead and start from scratch and create a new one. So we'll call this 3.2 Tech Tuesday network right here. So this is the namespace for my business network, my consortium. I'm going to click next. I'm going to whitelist one of our available clouds and regions. We see that we have 4 on AWS and 2 on Azure. So we can turn our network into multi-cloud, multi-region. These aren't binary fixed in time decisions. As your network evolves, you have new people join or offboard, you can add and remove regions accordingly. So here's the namespace for our business network, basically just a wrapper, first-class citizen. And now we can look at sort of the governance layer. So we'll click on this governance tab here, and I'm greeted with a memberships panel. Now, my organization is called Organization ABC, which we can see up in the top right, the org dropdown right here, and I'm automatically attributed the first membership. And you can do 2 things at this layer. You can create multiple memberships. These are all going to be owned by you, and this is useful for 2 approaches. If you want to proxy operate resources on behalf of another member, maybe someone needs access to send transactions, into the blockchain via their application, but they don't want to be responsible for billing or for true root admin ownership. This is a nice technique for that, sort of the proxy operating approach. So maybe organization XYZ, click add, and we see that it's actually owned by my root organization. This is also a useful technique for early stages in your projects where you want to try to mitigate expenses. You don't want to decentralize your network, but you want to sort of mimic, mock out how it's ultimately going to look. So we could pretend these are different financial institutions, different shipping companies, different pharmaceutical companies, what have you. And you can create this one-to-one tapestry topology of how the network will ultimately look, harden your application, harden your smart contract code, perform your internal or external demos, and then ultimately decentralize your network without having to change, any of the core application or business logic. So that's the membership approach. The alternate approach is to actually decentralize your network and send an invitation. Bring on an external organization that will have full unilateral autonomous control of their own resources. So maybe organization DEF, figure out who the root admin is and send them an email. And now, as the founder of the network, you can allocate or rescind permissions. And these are very, very straightforward, very intuitive, but you have the ability to dictate what people can and cannot do within your permissioned, authenticated, Kaleido business network. Should they be able to create blockchains? We call those environments. Should they be able to send invitations? Should they be able to create multiple memberships? Very straightforward, and these become, consortium level, business level conversations about, what expansive access control we need or what sort of, tempered access control we need. You send that invitation, and this is a 15, 30-second, very, very streamlined email-based onboarding to decentralize your network. So you can take the memberships approach, you can take the invitation approach, or you can do a combination of both. We see a ton of production consortia that have leveraged kind of this hybrid topology here. Multiple memberships owned by one organization, but also a decentralized network where you have different organizations owning and operating resources. Okay, so that's the network sort of control plane governance layer. Next, we want to go into the blockchain layer. So we'll go ahead and create our first environment underneath this consortia or underneath this business network. Now, this is where Kaleido is really cool. We give you very, very flexible, very configurable choices throughout your platform experience. So we give you two doors to go through at the protocol layer, Enterprise Ethereum and Corda. I'm going to take you through the Ethereum layer, but we do have recordings walking through sort of how Corda works and the different steps you need to make. So I'm going to create a name for my environment. We can have many environments in the business network. So you could have a sandbox, you could have dev, you could have user acceptance testing, pre-prod, production, etc. And then you can choose the orchestration, cloud only, or if there's a conversation, if you need support for a different private cloud or on-premise orchestration, you can reach out to us and we can talk more in detail about Kaleido Private Stack, which allows you to fully manage a node on your own mainframe inside your DMZ, for example. I'm going to go with cloud only. This is the easiest approach. So click next. And now we can go ahead and choose our protocol configuration. So with Ethereum, we give you 3 different node clients, Geth, Quorum, and Besu. And based on your latency, throughput needs, based on your chain layer privacy needs, you can choose different combinations that help support those project or InfoSec requirements. Quorum and Besu in particular have what are called private transaction modules. So they actually support chain layer private transactions where only a certain subset of the nodes are going to be able to fully execute that transaction and make sense of the inputs and the outputs for the global variables. So Quorum and IBFT tends to be a very, very popular combination. Geth and POA is a popular combination, and then Besu with proof of authority or Istanbul BFT. If you go to the Kaleido blogs, there's a very long scholarly article written by our head of protocol digging deeper into advantages, disadvantages, and just the nuances of these different algorithms. I'll take you through Quorum and IBFT as we see the vast majority of enterprise projects adopt this configuration right here. Okay, so as you're configuring your environment, you can actually implement more advanced settings. So you can attribute a custom chain ID to this environment, to this blockchain, and you can also manipulate the block period. So IBFT on Besu and on Quorum, it defaults to 10 seconds. But potentially, you want a higher block period. You can take it all the way up to 20 seconds, or you want to try to pack as many transactions into the network as you possibly can. You can take this all the way down to 5 seconds. IBFT and proof of authority, they default to mine blocks on fixed intervals. So it's not on-demand mining. If you instead choose Raft, that will give you on-demand mining about 50 to 80 milliseconds of latency right there. So if throughput and immediate finality is something that's really important for your use case or for your business network, Raft is an interesting consensus algorithm to consider. And the last thing we do, and this will go into sort of the next optional configuration, is we actually bootstrap every Genesis block with 1 billion fictitious Ether. They're real Ether, ERC20, it's a token inside of your network. And you can leverage this Ether pool, as we call it, however you see fit. So you can disseminate it and treat it like it's a fiat currency, treat it like it's a loyalty point, or you can use it directly with the protocol, and you can charge gas for your transactions. So if you want to, monetize invocations and change state changes on the network, you can leverage this pool right here. And rather than having it held on a default account, managed by Kaleido, you can actually attribute this Ether to external accounts where you hold those private keys, maybe a hardware wallet or some sort of external mobile wallet that you guys control. And then you have, extended admin control over, where that Ether goes. It's not a faucet that everyone can draw from. You basically drained the account, you bootstrapped the network with 1 billion Ether held, in a private Ethereum account that you control. So I'll go ahead and click finish, leaving the defaults here. And now we have a namespace for our environment, and we can just go ahead and bring it to life by creating some nodes. So I'll create node 1 for this membership, ABC. I can choose where I want to deploy it. I whitelisted all those clouds and all those regions. I can click next, I can choose the footprint size for my node. And this just goes hand in hand with the throughput that you're going to be sending into the network and the horizontal scale of your application. So if you envision a lot of traffic going into your nodes, a lot of RPC calls or a lot of queries, a medium or a large node might make sense. If you're having minimal transactions, not writing a lot of data to the blockchain, or just doing intermittent transactions, you can use a small node. And the cool thing with the node sizing here is that pretty much like everything in the platform, none of your decisions are fixed in time or binary. So nodes can be dynamically resized based on the requirements of your application, of your network. Take, for example, a financial network, and it's the end of the day, and a bunch of batch transactions need to come in to settle a bunch of different accounts, a bunch of trades that took place over the day. It's 3:45 p.m. on the East Coast, market's about to close, the transactions are coming in, you can upgrade your nodes to medium or large, send all those transactions, and then subsequently downgrade to small when the traffic is slowing down. So go ahead and click finish, and now you've brought your environment to life. Now you've created your blockchain. So I'll create one more node for our other membership, call it node 2. Click next, leave that as a small node, leave it as a signer, a proposer, and validator of blocks. And this guy will come to life here momentarily. So as these are initializing, I'll click back on my dashboard. And as soon as one of the node comes up, we can go ahead and click on the details, and we'll see the option to implement a bunch of additional protocol configurations. Specifically, we'll see the ability to charge for gas on the nodes, or we can change the logging level of the node, or we can choose to run the node as a full archive node or a light node. Lots of different techniques available there. And these configurations, again, they can be added, they can be removed. You simply need to create the object and then basically reinitialize your node with that configuration that you've implemented. So I'll drag my feet here for just a couple seconds while we watch these guys join and start into this environment. And then we'll look at that next piece of functionality. So actually, to be efficient, while these guys are coming up, I'm going to create a contract project super quickly. We've gone through this ad nauseum in the past, but essentially this is just a namespace for one or more compilations inside of our business network. This is a shared source of truth for the business logic that we're going to be executing on the blockchain. And what Kaleido does when you create a contract project and a subsequent compilation within it, we expose REST APIs for your smart contract. So you're not being tasked with having, Web3 application development skills. You can use just basic, web development, send post and send Git calls into Kaleido. And Kaleido will actually, do all of the heavy lifting that's required for Ethereum. Whether it's just signing a transaction, whether it's properly doing the nonce management and sequencing that transaction, all of the various gotchas that can creep up when you're doing Ethereum development. So here's a basic smart contract called simple storage. We've looked at this a lot in the past, but it's just a single variable that's a positive integer, and has a setter and it has a getter. So we'll use this source code right here, and Kaleido will go ahead and compile that for us and spit out the ABI, the bytecode, and expose really basic REST APIs for those methods we just looked at, namely set and get. So as this guy's compiling right here, I'll go ahead and hop back to our blockchain environment, and we can see that the system monitor started, and node 1 and node 2 have joined, and they will be starting momentarily. So as soon as they come up, I'll click on node number 1, and we'll look at some of the advanced protocol configurations that we can implement. So this guy's up, and I'm going to go ahead and click on the protocol configurations tab here. There's tons of rich metadata and additional details that you have access to. You have managed wallet that's with the accounts held on the node. You have event streams. We've looked at these a lot in the past. Really, really powerful, really cool. We're going to skip those today, and we're going to instead focus on sort of protocol configurations and key management and direct low-level role-based access control. So I'll go ahead and click on the protocol configuration here, and I can go ahead and edit a new object. So I'll click edit, and I'll just add a new configuration. So node number 1 is owned by membership ABC. So I want to create this configuration naturally against that same membership. So I'll just call this example node config. Again, this is really just going to be a JSON object that we bind to the node. Go ahead and click next. And now we see we can do some interesting things right here. We can arbitrarily modify the target gas limit. So maybe you have really complex smart contracts and, transactions are using, in the millions of gas, and you want to up that to, 5 billion or 10 billion or 20 billion, get crazy. You have the ability to do that. But again, if you do want to charge for invocations, state changes on the network, you can also implement a gas price. You can inject networking here. You can change the verbosity for your geth logs. We'll take a look at those as well. And then you can choose, which mode you want to run your node in. If you want to run it as an archive node, for example. And again, these, just like everything else, these aren't fixed in time. So you can create these configurations, you can create new objects, reinitialize, take them off the node as you see fit. Very, very straightforward right there. Okay, so that's the protocol configurations, and all of this is available in our documentation. Literally just docs.kaleido.io and search for advanced node configurations or protocol configurations, and you'll be greeted with those different parameters and those different customizations that are available to you. Okay, so we can go back to our blockchain dashboard. We see that all of our nodes have started. We can go back to our business network, go to our shared assets, go to our contract project, and we see that we have a successful compilation of that source code right here. We see the ABI, we see the bytecode, and now I can promote this code into my single environment. And the idea with the contract projects and the compilations is, as you're coming to Solidity for the first time, or you're doing more complex stuff with your smart contract code, you're not going to get it right. You're not going to get it perfect the first time. So this gives you a really easy, really elegant framework to, iterate, create your compilations, promote them to dev, promote them to UAT, and then take that exact same business logic and promote it to production. And the only thing that changes is a single endpoint inside of your application tier, an endpoint and some security credentials. So I'll promote this into that dev environment I just created. And what Kaleido will do is expose REST APIs for all of those methods that we looked at. So I can actually go ahead and view the definition of that smart contract. I'll look at it through the container or through the lens of node number one. So I'll have access here to all of the accounts that are owned by the node number one membership by ABC. We only have a single account, the default account that's held on the node. But what we're going to do shortly here is we're going to make a bunch of different wallets, and we'll have a bunch of different private keys that we can leverage to sign these transactions with. So the first thing we want to do is we have this definition right here, this gateway API, and we want to bring it to life. We want to actually turn it into an on-chain deployment. So I'm going to turn the Swagger into an interactive interface, and I'll just give it an argument to the constructor right here, 1, 2, 3, for example. And we want to look at this query parameter right here. This is what we're going to focus on today. This is where we're telling Kaleido, hey, this is the account that I want to sign with. At the moment, this membership, ABC, that owns the node we're about to send this transaction to, it only has this single account that's held on its node. But as we start making more accounts, or as we start making additional wallet services, we're going to be able to very easily leverage all of those accounts without having to do anything more. We just have to enumerate the account. So if we look at, sort of the architecture of this transaction tier right here, we're running 0 application code over here on the left, where you would typically have a client library. And we're just passing methods into the smart contract, and we're using 1 or more query parameters, specifically that KLD from parameter I just showed, to tell Kaleido, this is what we want to sign the object with, the transaction with. So what I'm going to do here is I'm going to instantiate it and sign it with an account that's held on the node. And then we'll take that smart contract deployment and start speaking to it. And we'll change the state of that variable with different accounts. So we'll sign it with an account that's held in an HSM service on Azure or on AWS. We'll sign it with an account that's held in an HD wallet. And what you guys can do is you can sort of marry this with your own projects and your own InfoSec requirements. Key management is oftentimes one of the most critical requirements, and it can be a huge impediment and a huge barrier to the velocity of projects. And if there is the requirement to have that key on premise, or have that key held in our own private AWS or Azure account, Kaleido can support all of those orchestrations. Okay, so we're going to instantiate it with the account on the node, and I'm going to give it a human-friendly name rather than dealing with a hexadecimal string. So again, we're on Quorum and IBFT with 10-second block intervals. So, this could take anywhere from, about 3 to 9 seconds for that full receipt to come back. So successful transaction. Again, we ran 0 application code. I can click back on the gateway definition right here, and I see that I have a new instance of this smart contract with its own address, and we can see even who instantiated it. We'll come back to this here shortly. Okay, so the next thing we want to look at is we want to look at how do we sign a transaction with a key held in one of those HSM services. Really, really powerful, security addition right there. So we need to do 2 things. We need to, again, create a configuration where we teach Kaleido, about our Key Vault service or about our KMS service. And then we need to have some access credentials so that Kaleido can make those encrypt, decrypt, sign, verify, get list calls on your behalf. So the first thing we'll do is we'll create a Cloud HSM cloud configuration object here. And you can see that there's a bunch of different classes that we can create for. We can create config objects for node encryption, config objects for backups, for log streams, for private traffic, or even for storage as well with our document store service. I'm going to go with a Cloud HSM object right here. So I'm going to use Microsoft Azure for this, but you can very easily do the same thing with AWS KMS, for example, or you can even use a HashiCorp server running, on-premise or in Google Private Cloud, for example. So we'll call this Azure config. Click next, and now I need to populate the various fields to sort of create this config object. And we can see that there's 5 different fields that we need for Azure. So what I'll do is I'll hop into Azure and we'll look at how this works. So it's quite easy to do on Azure, which is why I've adopted this approach. There's really just 2 things that you have to do. You need to create a client, or what Azure calls an application registration. And that's going to give you a user ID, that's going to give you an object ID and a tenant ID, and it's also going to give you an API key or a secret for authentication. And then you're going to take that application and you're going to give that application access to a Key Vault instance, to a key store. So basically you're saying, hey, this user, this OAuth instance, this app registration has these permissions to talk to my private key. It can encrypt, it can list, it can get, it can write. Basically, any of the things that Kaleido needs to do. What we need is get, list, sign, and verify. We can look at that shortly. So what we have here is I can go to Active Directory. I can click on app registrations, and I've created a registration called Kaleido HSM signing. So I can click on this guy, and we start to see all of the different fields that we need to populate on Kaleido. The client ID, the tenant ID, the object ID, and then we also need the certificate or the secret that maps to this client ID as well. So we're concerned with this guy right here, y.m, with all the redacted portions of the secret as well. So we'll go ahead and start building this config object super quickly. So the first thing we want is the client ID. And I'm going to cheat actually because I wrote all this down. So these are the same strings right here. So let me get the client ID first, and just bear with me. This is it's an interesting part of the demo, but this is going to take a little bit of copy and pasting. So just bear with me. So we want the object subscription ID next. That's this guy. Then we want the tenant ID. Now we need our vault name, Kaleido keys 1, and now we need that secret, that redacted string as well, which is right here, y.m. So none of this is particularly interesting. This is us just creating a configuration object on Kaleido. We also need the target address as well, which is just vault.azure.net. So this will just create a configuration object that's not bound to any resources on Kaleido. Right here, we see it's inactive, my Azure config object. And now we want to go ahead and bind that to an actual runtime, an HSM signing resource on Kaleido. Before we do that, let's look at the relationship of these services inside of Azure. And it would be a similar pattern inside of, AWS KMS or AWS HSM clusters as well. So I'm going to go back to the home and I'm going to click on my key vaults there, Kaleido keys -1. Open this up and we're going to look at the access policies here. And what you'll notice is that that application registration, I've given it a bunch of different permissions to do to this key vault service right here, Kaleido keys -1. I gave it every permission. I was experimenting with some other stuff the other day, but specifically really all you need is git list, sign and verify right here. So those 4 permissions will work perfectly for Cloud HSM signing. I was actually leveraging this app registration to do some stuff with disk level encryption, which is a Tech Tuesday that we'll be doing in the upcoming weeks with some partners in the industry. So I won't go down that rabbit hole or that tangent, but this is where you create that relationship between the client or the app registration and the core service that you're talking to. Okay. The next thing you would want to do within your Key Vault service, Azure Key Vault right here, is you'll want an Ethereum key. And specifically, all you need to do is pick the right curve. So the Ethereum curve is SecP 256K1. So as you go ahead and create a key, you're going to be tasked with providing a name for it. I have one called user1, I believe. And then you need to choose the type. Is it RSA or elliptical curve? And then what's the curve name? And again, for Ethereum, it's prime 256K1 right here. So you can choose if you want it enabled, if it's going to expire in a few months or something. But other than that, it's really that straightforward to fill in a few of these fields and go ahead and generate the key. You aren't going to be exposed with the raw address of the key, though. You're going to have a unique Azure identifier, and basically what Kaleido will do behind, under the covers is we'll do the derivation of that address for you, and we'll surface the address inside of your Kaleido HSM wallet service. So what we'll be looking at is this guy right here, Kaleido user number 1. This is the guy that we're going to try to sign a transaction with, and its address is 0x, and then it has 3 zeros and a 1, and 36 other characters inside of there. So we'll be able to actually surface that specific key here shortly. But this specifically is the guy we're signing with, which folks can tell very straightforwardly. This is not a standard Ethereum address. This is just the Azure ID right here. Okay, so hopping back into Kaleido, we created the config object. Now we need to create the HSM signing service. So I'm going to create an HSM wallet, call it Azure HSM wallet. We're going to bind it to ABC, which also owns that config object. And I'll just deploy this container inside of AWS. You actually don't have to, the HSM runtime doesn't have to be in Azure, even if it is an Azure config. So now I want to choose that object that this service is going to be bound to. So this is teaching this HSM runtime about all of that low-level Azure detail that we just created. So I'm going to go ahead and click Finish. And as this instantiates and comes to life, what we'll be able to do is we'll be able to click on this wallet tab right here, and we will actually see the derivation of that normal Ethereum address. We'll see that 0x, 3 zeros and a 1, basically what corresponds to this private key held in Key Vault right here. And we'll just go ahead and add a transaction. We'll change the variable for that simple storage smart contract using this address. So we need to start doing a little bit of copy and pasting right here. So what I'm going to do is I'm going to hop into another window that I have, and I'm going to look at the exact same stuff that we have right here. So I'm going to open up our Gateway API right here, and specifically our instance. So this is the guy that we just instantiated. I'm going to view it through node number 1. Again, node number 1 is owned by the ABC membership. The ABC membership owns that HSM service that we just created. So we can check for the current state of our global variable. We should get back 1, 2, 3. We do. And as soon as that service comes up, what we want to do is we want to upsert a new state, and we want to sign it with the HSM service. So cross our fingers that this properly instantiates here in the next few seconds, and then we can go ahead and view that address. And right after this, what we'll do is we'll look at the exact same technique, leveraging this KLD from query parameter, right, where we're allowed to enumerate the address, and we'll sign it with an HD wallet as well. And the HD wallets are particularly useful if you want anonymity, basically if you want to sign a transaction one time and just throw away that private key, or if you have hundreds or thousands or tens of thousands of end users, you don't want them to be the custodians of their own private keys, but you do want distinct compartmentalization and separation amongst the users. You want them all to have their own, specific Ethereum signing keys. And we'll look at that in just a second. So here's the service. It's started successfully. We can click on the wallet, and now we see that address properly derived by Kaleido 00016BE. And what I want to do is I want to actually copy this address, and then we can go into our Swagger interface. I'll do this with Postman as well, but it's really just, we're using an embedded REST client here. You can use a raw REST client to call these APIs. And I'm going to expand the set method. We'll give it a new value for the variable. It's March 2nd, so we'll give it 2. And now I'm going to change this parameter right here. Rather than using the default account on the node, I'm going to use that account or that private key held in the Azure HSM service right there. Go down here and click execute. And Kaleido will do all of that redirect for us behind the scenes. So that unsigned object that'll get intercepted, passed through to the Azure service, will get the fully signed object returned to Kaleido, and then that'll get submitted to your network on your behalf. And there in the receipt, we can see that it was signed by that address, by the private key in the HSM service. Again, this is just as easy to do with AWS KMS. If you're an AWS shop, you can do it with AWS HSM clusters, or you could do it with your own HashiCorp server running wherever the heck you want. So that's signing with the Cloud HSM service. Now what we want to do is we want to do the same thing, but we want to sign it with an HD wallet. So go down to your key management section and click on Manage Wallets. And what we'll do is we'll create a new managed wallet. And we have 2 types of managed wallets that we can create. We can create a standard managed wallet, pretty similar to just the node wallet, or you can create an HD wallet, a hierarchical deterministic wallet. Basically, it has a seed phrase, or it has entropy that will allow you to deterministically recreate 2.8 billion unique accounts inside of it. So I'm going to click Finish, and this will deploy an HD wallet service for us. And then underneath that service, what we can do is we can create 1 or more wallets, each of which will have its own unique set of 2.8 something billion accounts. So it really is a nice technique if you need an endless key tree of unique signing keys, or if you need to do immense end user management. And it is quite a nice technique for end user management. All you need to do is create some mapping in your backend. Nick Gasky maps to index 0 inside of this HD wallet. John Doe maps to index 1. So you do that internal lookup, and then you basically just populate this query parameter that we just looked at with the appropriate index. So as that service is coming up, I will go back to our gateway APIs, and we'll get ready to sign a transaction with the HD wallet. So we'll view this instance right here. Again, we're talking to it through node number 1. And I'm just going to expand this post in this set right here. So this should have come up, hopefully. Okay, stuff's taking a little longer, but it's a live demo, so wouldn't expect anything else. So as soon as this comes up, what we can do is we can start customizing that string, and we can start looking at the different accounts that are available within our specific HD wallet. And again, you're not limited to a single HD wallet. So maybe you have different user groups, for example, or different departments, different geographies, and you want a specific HD wallet for each of them. Very, very easy to do. And all you're really responsible for, on the Kaleido side, is just telling Kaleido about the specific wallet ID. All Kaleido wants to know about is this service ID right here, and then the wallet ID underneath it. So let's go ahead and create just a single HD wallet. And we see the mnemonic, we see that seed phrase or that entropy that will allow us to recreate all of the keys and all of the addresses inside of here. I'm not going to save that, but it is a good best practice to save it. And really what we just need here is we need these 2 IDs. We need the service ID, and then we need the specific wallet ID. So what we'll do is we'll just look at a very basic example where I'm going to sign a transaction with the first key that's available inside the tree right here, index 0. So we can fetch and we see 9E693F right there. And so that's who's going to be signing this transaction inside of Kaleido. So the first thing we need is we need this ID, the service ID. So I'll copy that, go back to Swagger. We'll give it a new value of 3 since we just did 2. And now, rather than using the node account or using the HSM account, we're going to use the HD wallet account. So HD-service ID -wallet ID, which is this right here, GXPNM. Copy that, and then tell Kaleido what index you want to sign with. We want 0, and we should see it from this address, 9E6. So there's the wallet ID. There's the index right there, 0. We populated the arguments for the method, and now we can just click execute. And again, under the covers, Kaleido is going and grabbing that private key on your behalf, signing the object, sequencing it, and submitting it into the network for you. And as soon as the receipt comes back, we should be able to look at that from parameter right there, and we see that it is index 0 inside of that HD wallet, 9E693. 9E693. Okay. So that is a nice example of signing with accounts that are on the node, signing with accounts that are held in the HD wallet, or signing with an HSM configured orchestration. Okay, pressing forward, I definitely lied about my 30-minute promise, but apologies. Feel free to drop if anyone does need to hop. Let's go ahead and take a quick peek at the digital asset support that we have in Kaleido. And namely what we've done is we've just given you templates for very standard ERC20 and ERC721 orchestrations. So you can speak to them through the REST API gateway, or you can just speak to them through very simple service APIs that we have. Everything in Kaleido is a very easy to consume and very easy to configure REST API. So we've tried to remove, any programming impediments that might occur with full stack app development or with just Ethereum. And we've done that specifically with digital assets and with tokens. So I'm going to select my signing account. We see here that Kaleido has even given me access to use that HSM account if I wanted. I'm just going to use the default account on node number 1. Create a token, and I'm going to use the Kaleido token factory so that I have to do 0 customization. I don't even have to link into OpenZeppelin for my ERC20. So I'm going to go with the ERC20 mintable burnable, and the full balance is going to be owned by that default account on node number 1, and I'll be able to do much more interesting things with it. Approve different addresses to spend those tokens. I can transfer those tokens. I can mint them, burn them. Do all of the methods that are available inside of those richer ERC20 or ERC721 contracts. So Kaleido will surface this template for us, and then we can proceed to customize it with the initial balance, with the number of decimals, and with a symbol and with a name. We'll do a very basic one for loyalty points, I guess. So this will manifest here in just a few seconds, and we'll see that we have the ability to customize it directly within the dashboard, or we can customize it within our Swagger or within a raw REST client like Postman as well. Multiple ways to deploy these smart contracts on the network. The other thing I should go back and mention as well, we looked at the REST API gateway and saw how easy it was to speak to the blockchain with that approach. If you're already have an environment on Kaleido and you've already instantiated some contracts with a Web3 library, that doesn't prohibit you from still leveraging the REST API gateway. You just need to teach Kaleido about the ABI. And then you can go ahead and use the existing smart contract address. You can use that as another query parameter, and you can speak to that exact same smart contract without having to use a Web3 library. Or maybe you still want your transactions coming in with a Web3 approach, but you don't want to do WebSocket polling for events. You can teach Kaleido about the ABI, and you can use our event streams for reliable JSON payload delivery to an API gateway in front of a Lambda function or directly to your application. There's no one size fits all basically right here. You can configure and you can get as flexible as you need to be. So I'll create one called loyalty points, give it a symbol called loyal, and basically just choose the initial supply. I'll give it 100 and 2 decimals, so 10,000. and I can just go ahead and deploy this. Again, I could view the factory API, and I would have the Swagger interface to do the exact same actions that I'm demonstrating here. So we'll bring this to life, and what we'll see is that I have two gateway APIs now. I have an API called Kaleido ERC20 mintable burnable, and underneath it, I'm going to have an instance with this address right here, 2D53. So I can close this out. I can go back to my token dashboard, digital assets dashboard, and we see I have the ERC20 loyalty points token. I'm going to select the signing account, and we'll see all of these grayed out actions become available for me. So we'll select that default account on node number 1. You can see the balance. I could transfer it, I could mint it, I could burn it. We can do a quick transfer to our other organization, maybe give them 100 of our loyalty tokens. We'll give it to the account on our other membership, node number 2, click transfer. And again, very easy API underneath this, or you can talk directly to the Swagger interface or to that smart contract instance. So that transaction was successful. We can go back to the dashboard. We can click on this. We can go and click on the address right here. We can, see all of the transactions that have taken place. Boom, there's that one. We can click on it. We can see the inputs. We can see who signed it. Everything's available to you in the dashboard or via the APIs. That's kind of the takeaway here. So I was speaking to it through the dashboard. Again, there is a default instance or an API created for it. And just like with simple storage, we could view this instance, speak to it through Swagger, speak to it through a REST client or an application. Okay, last thing to cover is perhaps the most interesting thing. It's the lower level role-based access control that we provide in Kaleido. So I'm going to go back to my environment dashboard, and I'm going to show a picture first of what we let you do here. So this is going to be a very vanilla 101 demonstration of what this service allows you to do. But please bear in mind that you can get as granular and elaborate and sophisticated with this service as is required by your application, by your project, by your business network. And the idea here is that you can set rules, basically. At a very high level, you can teach your node about a bunch of different rules of who is allowed to do what. If someone's authenticating into the network with this JWT, what are the things that they can and cannot do? If someone is, authenticating into the network with this set of app credentials, what address do they need to sign with? What smart contract address can they call? What methods can they exercise? And this is a really elegant flow here. It'll redirect into your existing LDAP, your existing IAM instance. You teach Kaleido about a public key that can verify a JWT. And inside of that JWT, you have a set of rules about what that user is and is not allowed to do. They might try to sign a transaction with a private key that they're not allowed to use, and you'll see that that call is unauthorized, unauthenticated coming into Kaleido. If they fulfill what they are allowed to do in the network, basically if their claims map the configured rule set, then that call will succeed inside of Kaleido. And what we're going to look at is we're just going to look at creating a unique set of application credentials and then dictating what smart contract or what Ethereum address, can be used to sign transactions with that set of application credentials. So inside of our network right here, what I'm going to do is in the apps and integrations, click on the application firewall service. And I'm going to create my first policy. I'm going to call it policy number 1. And I'm going to bind it to ABC, and we're going to apply this firewall in front of node number 1 on the platform. So I'm going to click finish, and I see that I have a default rule set, admin, who's allowed to do everything, and that I have an initial claims mapping right here. Admin is our first claims mapping. So what we want to do is we want to create a rule set here, and we'll just call it user 1, for example. We're gonna pretend that we have an end user who has access to a set of valid application credentials, and we want to dictate that they have to sign transactions with that private key in the HSM, or they have to sign transactions with the private key that's held on the node, for example. So I'm going to create this rule set user number 1, and actually what we want to do is we want to create another account on node number 1. So I will go back to my other view right here, click node number 1, click the wallet, and we're going to create a rule set that says, hey, they're going to use these credentials and they have to sign with this private key right here with this address. So I'm going to go ahead and copy that. And this is going to be the from address rule that we're creating. So user 1 has to sign transactions with this address right here. So it doesn't want the 0x. But you see that you can do many, many, many more interesting things. You can dictate which smart contract they're allowed to call. You can dictate if they're allowed to read or if they're allowed to write. You can dictate, lower level chain operations, account operations. Very, very, expansive and sophisticated as you require in your network. And you can reconfigure these or remove these after the fact as well. So this is just a very basic one, right? User number 1 has to sign transactions with this address right here, okay? Now what we want to do is we want to bind that rule set to a set of application credentials. So I'll go into my security tab and I'm going to create a new application credential. Call it BAF creds, blockchain application firewall credentials. So click create, and this is the ID that we're going to bind to user number 1 rule set. So copy that guy right there. I'm going to regenerate this password as we start using the REST client. Okay, lost my space. Apps and integrations, application firewall, policy number 1. Okay, so this is what we want to do. We want to create credential mapping, and we are going to provide the username for that set of application credentials, and we're going to bind it to that rule set that we named user number 1, where we dictated what address they need to sign with. And you can, of course, use metadata. You can use descriptions to help you make sense of these right here. And I'm just going to click finish. So now we can see here that we have our claims mappings. We have admin and we have user number 1. And one important thing here is that anything that fulfills the admin rule set, which is any valid application credentials, is going to succeed into the network. So we won't actually see this RBAC enforced unless we change the order. So it's going to look to fulfill this user set first, this claims mapping first. If it's not fulfilled, then it just logically goes down the list and it will succeed with the first claims mapping that it fulfills. So we want it to actually default into this user number 1 that we created right here. Okay, so we have that, and now we need to attach these definitions, this firewall configuration, to one of the runtimes in the network. So I'm going to attach it to node number 1, which is also owned by the same membership that created this object. And then we need to apply it. So we've attached it. It's basically like in the staging bucket of the node. Now we need to inject it into the runtime. So we're going to go ahead and apply this config. And what we'll see is we'll see a reinitialization of the node. So basically mimicking what happens when it comes to life when you create an environment. Initializing, joining, joined, and then started. You'll see all of those state transitions occur right there. Okay, so as that guy is coming to life, what I'm going to do is I'm going to doctor up a REST client so we can speak to the network. So I'm going to go ahead and copy this username and password. So we're going to send a post call into that smart contract instance, that simple storage instance, and we're going to try to sign it with an address that does not fulfill that rule set and that claims mapping that we just created. So here's the username and the password. Again, this is the application claims mapping that we just created, FYM. Here's the password, WGR. Okay, and then I'm going to create a few other additional headers right here. So x-kaleido from, this is our query parameter, where we're going to enumerate the address. And then x-kaleido sync, this is saying poll for this transaction to fully execute. So I'm going to call this true right here. We're going to give it a JSON body. And then we need to provide the endpoint for our Swagger instance, for our smart contract instance. So I will go into the gateway APIs, go to simple storage, and this is the endpoint that we want right here. So view instance API, view it through node number 1, and we want, oops, doing too many things. We want this endpoint right here. So we're going to give this, this is basically just the ETH Connect interface sitting in front of the node. So we want to give this HTTPS, this right here. So here's our instance. We want to call the set method. And inside of our body, we just need little JSON payload with our arguments. So I'm going to give it, we'll give it 4 this time. And what we want to look at is we want to, assuming I configured all of that properly, we want to give this a smart or a Ethereum address that does not fulfill that claims mapping for this set of application credentials. And we should expect to see an unauthorized response from Kaleido. So if we go back into here and confirm that this has been successfully applied and attached, we can now try to sign a few transactions. So the first one we'll try with is we'll try to use one of the addresses that is not allowed, right? We're basically going to not use this address right here. This should be the only address that succeeds, that makes it through the network. So we can click on node number 1, and let's just try with that default account right here, 6B7. So we can copy that guy, go back into our REST client, and provide it with that value. So we have our username, our password, our application credentials. Again, this is that user ID that we did the claims mapping for, FYM. If we look at this, we should, sorry, keep, FYM right here. So this is what we've dictated. So let's go ahead and try to send that transaction into the network. So this was unauthorized. This did not fulfill that rule set, that application firewall policy that we created. Now let's go ahead and try to change that address to what we said it can sign with. So we'll go back and we can grab this guy right here. Let's leave the 0x and then paste that. And if we try this exact same call again, also assuming I didn't screw anything up, this call should actually make it through the network. This should make it, into your ETH Connect container. This should be able to bypass your firewall proxy right there and turn into a properly signed and sequenced Ethereum transaction object. And it did, right? We see the from address, and this is what we map to with that rule set and with that claim mapping. And again, I didn't do anything terribly interesting here, but this is just a high-level example of, some of the rules that you're able to dictate. Namely, what you would want to do is you'd want to say, the end user has to sign with this smart contract address or with this Ethereum address, and they can only call this smart contract, and they can only exercise, this query method, or they can only exercise the transfer method in your token smart contract. Just some of the high-level examples there. And then we can go ahead and click on our data explorer, and we can see all the transactions that we just sent into the network. We can see our instantiations, we can see our token smart contract, we can see the most recent transaction that we sent in that fulfilled the blockchain application firewall policy. All of this data is available to you as admins, as operators. Okay. So I did leave 6 minutes. I'll pause and see if there's any questions. Don't see anything in the chat right off the bump, but just want to make sure if there are any technical or commercial questions, please don't hesitate to put them in the chat. Or what I'll do is I'll actually share my email address. I will share how to get technical assistance. And then for commercial outreach, contact sales@kaleido.io. So all 3 of those URLs are available in the chat for folks. This is recorded. This will be updated and posted to our YouTube page. We're continuing to add some pretty cool things into the platform behind the scenes. So please stay tuned for more functionality and more demos. And we have some industry partner demos coming up in the very near future as well. And we'd also love for you guys to reach out and just tell us if there are specific things that you're interested in. If you want to see more use case specific demos, if there's functionality on the platform you want to see, if you want to dig deeper into key management or into events, you know, anything's on the table. We're happy to customize these for the market. Okay, well, I don't see any comments in the chat. I want to thank everyone for attending today. And again, I hope everyone's staying safe and staying healthy. And yeah, have a great day and stay tuned for more materials on future sessions.